Hi there and welcome to another UnityFS tutorial. I've been getting a number of requests recently about how to set up mobile controls in UnityFS and also how to take advantage of the new UnityFS input system that's come out in the latest update. So what I'd like to do in this video really is just take the opportunity to show you how the new input system works, the options that are available, the power that gives you, and also show you what we can do to set up UnityFS so that it will run on a mobile device. So this tutorial will hopefully cover both of those topics. So here we can see we've got the standard example scene. I've actually created a new scene. I've pulled in my test scene objects, which gives us the floor and the camera, and then I've also just pulled in the example aircraft prefab, which we can see here. Now the first thing I'm going to do is just make these gizmos a bit bigger. First thing I'm going to do is just select my wing and just have a look at my standard component view here and see what we've got. And you'll notice here that if we come to the control surface, the menus here have changed a little bit. So previously we would just have the surface axis name here, but what we've actually got now is this option here, this drop down list, which gives us 3 different input modes, and it's these 3 different input modes which really add a lot more power to UnityFS. So you can see here that currently for all of the existing control surfaces and inputs, and the same goes for the engines as well, we are using the source of input manager, and that is linked to the Unity input settings. So if we go into project settings input here, you can see that we've got all these axes defined: pitch, roll, yaw, throttle, landing gear, view, zoom, etc. And if we click on our wings, you can see that we're using the input manager as a source, and then we are referencing the name of the axis here, in this case roll for the wings. Some of these components have multiple input pickers on, so the wing, for example, the engine, for example, we've got one input source for the throttle, and we've also got another input source for the ignition here, and you can specify different input sources for those if you wish to. So I think the first input source, input manager, is pretty self-explanatory. This essentially just allows you to specify a string, which is the name of an axis. UnityFS will then pick up whatever inputs coming through the Unity input manager, and it will use that to drive the control surface. There's also the option here to invert that input if you wish for a given control. Now the second one, which is probably the most interesting and also the most powerful, makes use of something called reflection, and this allows you to select any game object, and from that game object use it to drive the control surfaces without having to write any code. I'm going to explain that again, hopefully more clearly and more slowly as we go on. So what I've done is I've selected reflected here, and what we can actually do is select then any game object at all. So I go into my scene here, you can see there's lots of game objects. So let's pick, say, a camera. So we've got the orbit camera here, and then once you've picked your game object, you can then select which component you want to reference, which component has got the variable you want to drive the control surface on it. So in this instance we can pick the orbit camera component, and then from that we can then pick a float, and that float will be used to drive the actual input for the control surface. So in this instance we've currently got the input for this control surface driven by the camera Z offset. We could set it to camera Y offset, and then whatever we do with this value, or whatever this value does on that component, will then change the movement of this wing. So currently UnityFS can take in 3 input types, so you can point it to any type of game object and then any type of component, and then in here you can point it to either a float value, a vector 2, or a vector 3. With vector 2s and vector 3s, you will then be given the option to select either the X, Y, or Z axis from which you want to drive the input. The main, obviously, input type that is used is a float, and UnityFS expects that to be in the range of -1 to 1. So let me just go over that again quickly. We've currently covered 2 of the input types. You've got the basic input manager type, which is as it was before, which links to Unity's standard input system, where you can just define the name of the axis. And what we've just been through is the reflected version, and this allows you to point at any public, I didn't say that before, it's going to be any public variable of either float, vector2 or vector3 on any game object, on any component, and you can use that to drive your control surface. Now, where this gets really interesting is what I'll show you in a minute for when we come to mobile, because what we can do then is we can pull in the standard Unity mobile input controls, the joystick controls, and we can link straight up to the joystick input values with this without having to write any code at all. Or similarly, if we got other joystick controllers or on-screen controllers off the internet, or wanted to even write an AI system, we can use reflection here to grab those values to drive the aircraft's input without having to write any code whatsoever. So that is the second input system setup. What's also nice about this is it remembers the settings. So if you wanted to go back to Input Manager, you'll see here that it's still remembered that the axis name is roll when you go back. And similarly with reflection, that's come back. So the final method then of input is actually what's called manual input. And you'll see here the little helper window comes up when you select this. Manual input allows you to, from code, specify the input value you want. So what you can do in your C# scripts or your Java scripts is get a reference to this game object, get a reference to the control surface, and then from that control surface you can get the public input controller, which I think in this instance is called controller, and you can call this function to manually set the input for that. So if you don't want to use reflection, you can directly hook into the control surfaces through code and then set input that way. Okay, now that we have looked at the new input system in UnityFS, I'm just going to show you what you can do, or sorry, the steps that are involved in getting UnityFS up and running on a mobile device. Now, UnityFS out of the box is designed to run on mobile, which means that to build on mobile, you don't have to do anything special other than hitting the build button in Unity. All of the components will work, all of the physics will work, everything UnityFS will work on iOS and Android out of the box. The one thing that you will need to do, however, is to set up the input. So I'm just going to show you how we can set up the input out of the box to run on mobile, and then also just a few little tricks that you can do to help improve your performance on mobile, or at least show you just how flexible and scalable UnityFS is when it comes to mobile development. So the first thing we're going to do is we're going to go to Assets, Import Package, and pull in the standard mobile assets. You'll see here that this pulls in a whole bunch of stuff, but the main things we're interested in, if you've not seen this before, is that inside the standard mobile assets are some on-screen joysticks, and this is what we're going to use to drive the input. So I'm just going to pull that in now. Hopefully that won't take too long to import. Okay, there we go. So if I look at my project now, you'll see that there is a standard assets mobile folder which has just been imported. If I open that up and look in the prefabs directory, you'll see it in here are the joystick prefabs that I mentioned, and one of those is dual joysticks. So if I drag that into my scene and now look at my game view, you will see that I have two GUI joystick buttons which are visible on the screen. And if I open this up, you can see here we've got our left joystick with a joystick component on and a right joystick with a joystick component on. Now, if we just explore these joystick components, you'll notice that on these there is a public variable called position, and this is a vector2, and it's got an X position and a Y position, and these positions relate to the offset of these joystick buttons. So the X offset is the left and right offset of the joystick, and it goes from -1 to +1, and the Y position is the Y offset of the button, which goes from, again, -1 to +1. Now the great thing about this is because we have this value here from this component, we can actually just hook up to this directly using the Unity input system, and we don't have to write any code at all. And I'm going to show you how to do that shortly. Now, unfortunately, one of the things I will point out, if you've not used the joystick controllers before, these joystick buttons, unfortunately, they don't take in mouse input. So you can't actually test them as standard on Windows. You have to build onto iOS or build onto Android, and then they will work. If you search on the internet for this, actually, there's been a number of people that have modified these scripts slightly to also accept mouse input as well as touches. So you can download these and modify your input so that it's easier to test on Windows. However, just for the sake of showing you the absolute basics and what you can do with the existing Unity setup, I wanted to just use the basic package and show you how simple it is to get UnityFS up and running. So we've got our two buttons or joysticks set up. These have got axes. The next thing we need to do is actually point our control surfaces at these buttons. So the first thing we need to think about is what we want each joystick to control. And I think what I'm going to do in this instance is use the left joystick, use the up and down or the y-axis for the pitch. So that will control the elevator at the back of the aircraft to control the nose up and down. We're going to use the x-axis on the left joystick, that's this one here, the left and right, to control the roll of the aircraft. So that's the ailerons on each of the wings. On the right joystick, I'm going to use the y-axis, which is the up and down axis, to control the throttle on the engines. And I'm going to use the x-axis, which is the left and right axis, to control the rudder on the back. So if we come to our scene view, what I'm going to do is select my outer wing, my non-mirrored outer wing first. And then what I'm going to do is on the input source here, change this to reflected, point it at our left joystick. Then I'll be given the option of selecting which component on that game object I want to reference. So I'm going to reference the joystick component. And then from there I can select any public field of either float, vector2 or vector3 type that I want to use the value from. So in this instance, as we said, we want to use the position vector2, and as it's a vector, I can then specify which axis I care about. Oops. So for left and right, we said we'd use the x-axis. So here you can see I've already got that selected. So we'll do the same again for the opposite wing. So we're going to change to reflected, left joystick, joystick component, position, and x-axis. For the y-axis, we said we'd control the elevator, so we'll come to our elevator, change to reflected, oh, missed, change to reflected, point it at the left joystick, joystick component, position, and then y-axis, and then the same for the other side. Oops, reflected first, left joystick, joystick, position, y-axis. And now that's it. That is the left joystick fully hooked up. There's nothing else you need to do. You don't need to hook any code up. They all just work. So now we can go to the right joystick. And so we wanted to use that to control the engine. So I'll select my engine, my right engine. So the top one here is the throttle source. We'll change that to reflected. Point it to the right joystick. Select the joystick component, position, and Y. Do the same for the left engine. Oops, I'm pointing that at the wrong thing. So that should be right joystick, joystick, position, Y. Just check I didn't do that on the first one. No, okay, so that's the engine setup. And then finally, we want to set the rudder up. So here we go. We'll set this to reflected. Point that at the right joystick, the joystick component, and the x-axis. That's correct. So now we've got our wings looking at our left joystick and our elevator looking at our left joystick, and we've got our engines reading from the right joystick and the rudder reading from the right joystick. And that is it. If we were to build this now on mobile and run it, if you were to move these joysticks, you'd see the control surfaces move and you'd be able to fly around.